21.32. A uniform electric field exists in the region between two oppositely charged plane parallel plates. A proton is released from rest at the surface of the positively charged plate and strikes the surface of the opposite plate, 1.60 centimeters distant from the first, in a time interval of 3.2 times 10 to the negative 6 seconds. Find the magnitude of the electric field and find the speed of the proton when it strikes the negatively charged plate. Alright, so we got a plus plate. We got a minus plate. We got a proton going that way. Because protons like to go from plus to minus. They follow the electric field. So our electric field getting set up in here is going to look like that. Okay, so we know that the distance is 1.6 centimeters, and we know the time it takes to get over there is 3.2 times 10 to the minus 6 seconds. So that means we can figure out a lot of stuff from kinematics. Like, say, part B, find the speed. So what are all of our kinematic equations? V final equals V initial plus AT. V final squared equals V initial squared plus 2A delta X. Y final equals Y initial plus VT plus 1/2 AT squared. What's the other one? I totally forget. The other kinematics equation. VI plus AT. V final squared is VI squared plus 2A delta X.
Delta V equals 2AD.
Yeah, I have.
Oh, yeah.
I have that one. Or am I just thinking the X final equals X initial plus probably? That's probably the one I'm forgetting. That's for constant speeds. Okay, so we don't know our final speed, but we do know that we are starting from rest, but we don't know our acceleration yet either. So we're not going to use that one, we're not going to use that one. And we know there's acceleration, so we can't use that one. All right, sweet. So Y final equals Y initial plus V initial t plus 1/2 AT squared. I'm starting from rest, so that's 0. If we say that this is 0 and this is 1.6 centimeters, then that's also 0. So we can find our acceleration. So our acceleration is going to be 2. I'm going to change this to d, because that's what I called it up here. So 2d over t squared is equal to a. So I did that by multiplying my 2 over and dividing by t squared. Alright, so my acceleration is 2d over t squared. But they want us to find the magnitude of the electric field. So I'm not going to plug in numbers yet, because then it's going to get gross. Alright, so force equals mass times acceleration. So that means our force is 2 mass times distance over t squared. And we also know that force equals Q times the electric field. So that means 2 md over t squared is equal to QE. So my electric field is 2 md over q t squared. All right, now I'll plug in numbers. So my mass, it is a proton, yes. So 1.67 times 10 to the negative 27 kilograms. The distance is 1.6 centimeters, so that's 0.016 meters. Q, it's a proton, so it's 1.602 times 10 to the minus 19 coulombs. And the time was 3.2 times 10 to the negative 6 seconds, and that's squared. All right. 2 times 1.67 times 10 to the minus 27 times 0.016 divided by 1.602 times 10. That is not the times 10 button. Times 10 to the minus 19 times 3.2. 3.2 times 10 to the minus 6 squared. That is, oh my god. Ah! Shit. I don't know how to work a calculator, guys. Fun fact. Okay, so 3.2 times 10 to the minus 6 squared. So my electric field is 32.58 newtons per coulomb. All right. Now I can find my final speed. My final speed is V initial, which is 0, plus AT. But A was 2D over T squared times T. So you can't see what I'm writing. Wow, sorry guys. So one of my T's cancels out. So that's 2D over T, which is equal to 0.016 meters over 3.2 times 10 to the minus 6 seconds. So 2 times 0.016 divided by 3.2 times 10 to the minus 6. Okay, ow. 10,000 meters per second. Notice it is less than the speed of light, so that's a reasonable answer. All right. It's going super fast, but still a reasonable answer.